Okay, so let's discuss about the connection pooling. So to understand the connection pooling, let's take a very simple analogy where let's say you want to climb from the ground floor to the first floor. So for that, what you will do, you'll just pick a temporary wooden staircase and then you will place it properly, and then you will climb up, and then you will just remove that wooden staircase from that place so that no obstructions should be there on the road, and then you will place it somewhere at a safe place. And then once you want to come back down, then you'll just place it again and then it'll come down, right? So this is exactly what happens when you get a request or an API request to do some database operation. For example, let's say you want to add a customer. So your application will receive a request to add a customer to the database. Then first, what the application needs to do, it needs to establish a connection with the MySQL or the SQL database or whatever the database you are using. So for that, it needs to do this network connections where it needs to do three-way handshake. What does that mean? It needs to first send an acknowledgement request, then it will get a synchronization response, and then both needs to acknowledge that, and then the connection will get established, and then the data will get transferred. And once that is done, it needs to again remove that connection. Okay. So for that, again, two network calls are done that we call it as two-way tear down. So overall, for this data transfer from your application to the database, we needed to make at least 5 network calls, right? And this is just for one operation. So now let's just assume or just think when we have multiple or many number of requests coming to the application, they can be read operations or they can be write operations, right? So for every operation, the application needs to make a connection to the database. And for this, it needs to do all these network calls, right? So this is exactly like how we are doing here, where for every, for whether I need to go up or I need to go down, I need to just place the staircase every time, right? So now this is what we can overcome with the help of connection pooling. So with the connection pooling, we can configure in the application like how many connections the application should maintain when the application starts. So that, let's say if I say 5 as a number, which I will show you next, then once at the startup time, the application will create 5 connections with the database and it will maintain those connections. So it is like constructing a permanent staircase where you can just come up and go up or go down without worrying about placing a staircase. So this is what the application will do once you configure the connection pooling. So let's say if you have configured 3 or 5 connection pool as the pool, then it will make 3 connections or 5 connections with the database and it will keep that persistent. So once you get any request, it will use that existing connection to do the operation. So this is how you will save the network calls. Okay. So that's one of the main reason why you need to use the connection pooling, and it will also reduces the response time, right? Because doing these 5 network calls takes some time where the response time will get increased. But if these network calls are avoided by connection pooling, then the response time will get decreased. Okay. So this is a basic understanding of why we need the connection pooling. Next, we'll discuss like what are the major advantages and what are the major disadvantages of having the connection pooling. Okay. Okay, so if we look at a couple of advantages and disadvantages. So the first massive benefit we will get, as we discussed, is the performance boost. So when we do not have to do this handshake and tear down for every request, that will eventually increases the performance. The response time for the APIs will massively get reduced, and we will get a consistent performance under the load. So for example, let's say if we have some connection pool and we immediately get a very high load, then our application will be able to manage or handle that high load. So this is a major advantage of having the connection pool. Then the reduced database load, right? So that's on both the sides actually. So whenever we want to establish a connection, as we discussed, there are multiple network calls and the overall the resource overhead will be there, right? The CPU will get utilized. So all these things gets avoided if we have the connection pool. And then if for example in the Spring Boot application we have a library that is Hikari connection pool that will take care of this connection pool. So if we have configured this, then if any of the connection gets dropped, then it will automatically try to establish the connection so that the pool gets maintained, right? So these are some of the benefits that we can see when we have configured the connection pool. But at the same time, we have a couple of disadvantages or drawbacks, like first of all, resource overhead. So when we maintain the connection pool, then on both the sides, that is on the application side, also on the database side, it needs to reserve some amount of CPU and memory and some amount of threads. Okay, so those threads and the memory get reserved for this connection, and that cannot be used. So we should be going ahead. We should go ahead with connection pooling only when we have such requirement. Only when we can compromise on the threads and the memory. Okay, so once we see some massive advantage at other end, then only we should go for the connection pooling. Then we other disadvantage is resource waste. That is nothing but, let's say we configured some connections, we have pulled some connections, but we do not see that traffic, or we do not see that those many requests. Then those connections will get wasted. The resource get wasted. And another major impact that we can see is when we misconfigure these connection pooling, right? So when we configure this connection pool, like which I'll show you next, at that time we need to add a couple of configurations in the application. So those configurations needs to be added very meticulously. So we need to just do some couple of calculations before we add those configurations. Otherwise, if we misconfigure, then over at a high load, the application will get failed or the request will get failed. So I will show you both the positive and negative scenario next, like what happens if we misconfigure the connection pooling, right? So these are the couple of advantages and disadvantages that we can see when we do the connection pooling. Okay, so next let's see how to practically implement the connection pooling. Okay, so here I have created a simple Spring Boot application, and I have added 3 dependencies. The first one is Spring Data JPA, that is Java Persistence API, that will help us to interact with the database. Then I have added the Spring Web dependency that will help us to create the REST APIs and also to run the Apache Tomcat container in which our application will start. And then I have added the SQL connector JDBC driver that will help us to connect to the database. Okay, so next I have added a very simple code in the starter class. So here I have implemented the command line runner that will call the run method once the application starts, and it will in return call the run concurrent updates. Okay, so in this method I have added a multi-threaded code where first I have added an executor service, and that will help us to create multiple threads. Then I have added a countdown latch, so that will help us to simulate a behavior where we will first launch the number of threads as we need. So here that is 10. So once all the 10 threads are ready, we will just count down, like we'll make this count to 0, and then the latch will get open, and all the 10 threads will try to do the operation on the database simultaneously. So this is the behavior that I wanted to simulate. So for that reason, I have used these two, that is executor service and countdown latch. So inside the for loop, for every new ID, a new thread will get created, and that will go into waiting state until this for loop gets completed. So once the for loops get completed, the main thread will come out of this for loop, and then it will just wait for 2 seconds, and then it will do the latch.countdown. So what this will do, this will just reduce the count from 1 to 0, and the latch will get opened. And the moment it will get opened, all the 10 threads will get executed, and these 2 lines will get executed. Okay, and that will just do the database operation where I have a table, my table, in that it will just increase the count. Okay, so next I'll just show you the table. So this is the overall flow of this code. Okay, so next I have in the application.properties, here I have configured the database details. So I have created a SQL database in AWS, that is RDS. Here, let me just show you. I hope you must be knowing how to create database. If not, so here you can just search for RDS in the AWS, and here just click on databases, create database. So here I went with easy create MySQL, and for this is just for a testing purpose. So let me just refresh this. Easy create MySQL, and here let's go with free tier with 1 GB of RAM and 2 virtual CPU. And here you can just give all these details, username, password, and you can just click on create database. Okay, so once you will do this, the database will get created. And for public accessibility, you need to go here and modify. Under modify, under additional configuration, you need to enable this as publicly accessible. So initially it should be not publicly accessible, so you just enable it as publicly accessible, and then you can just click on continue, and here just click on apply immediately, and just you can click on modify database instance. So post that, your database will be publicly accessible so that you can access it from your application. Okay, so now coming back, here I have added those details. Next comes the very important thing, that is the connection pooling details. Okay, so here the first property tells us the maximum number of connections this application can create to the database. That is this one instance of the application. What do I mean here? Let's say here, let's say we got around 100 requests, 100 different requests from different users for some operation. Let's say we have developed a e-commerce application, and we have announced a flash sale, and there are many users who want to buy something, and let's say there are 100 users as trying to do some operation. So you got 100 requests. So in this case, when the application needs to make a connection to the database, at max it can make the 10 connections. Okay, so of these 100, only 10 will get served at that moment. Okay, so other 90 requests will be in a waiting state until this 10 gets completed. So every request, if the operation is very small, like just a select statement or read statement, then it will be hardly of any milliseconds. Okay, so in 1 second you can definitely able to like do all the 100 operations. Okay, if they are just simple read. Okay, so in this case, now just if we assume here, like if one request will take 1 second, then in that case, for the first initial 10 requests will be completed in 1 second, because at max this application can make 10 connections to the database. And in the second, after 1 second, in the next 10 second, in the next second, the next 10 requests will get served. Here I'm just talking ideally. This is not exactly how the application will work, but just to make you understand what does this maximum pool size is doing here. So at max, the application can make 10 connections at any point of time. Okay, not more than that. Next property we have is the minimum idle connections that can remain. Okay, so this is where we establish the connection pool. Okay, so right now here I have made it as 0. That means once the application starts, the application is not going to make any connections beforehand. Okay, so it will not make any connections. Now if I change it to 5, let's say, so what the application will do before it completely starts, it will first establish 5 connections with the database. But if the database doesn't allow these many connections, then the application will start to fail. Okay, so it will first establish those 5 connections, and then the application will start. Okay, and those 5 connections will be maintained, will be persisted throughout the application's life until you kill the application. So those 5 connections will be maintained. So those are the ideal connection, and this is what the connection pooling is. Okay, so now how many ideal connections we should keep, that is completely dependent on the use case. Okay, and next we will see a couple of more scenarios that will also make you clear on this. So I hope you were able to understand what is minimum idle. And here this should be always less than the maximum pool size, right? Because if let's say the pool size is 1, and if I do minimum idle connection as 5, then it's against the property, right? Because I cannot have more than one connection, and here I am saying it should be 5, then this is an error state. So that cannot be done, right? So let me make it as 10 and let me keep it as 5. Next, we have the connection timeout. So this is very interesting property that we need to configure very correctly. So here, what does this do? Now let's come back to the same example where we have hundreds of requests, and in the first second, in the first moment, when the 10 connections are done, so there are still 90 requests or 90 requests that are waiting for a database connection. Okay, so now for these 90 seconds, we are setting a time over here, like for how much time these 90 requests will wait before that get failed. So what happens once the request comes, the application will call the Hikari pool, that is the Hikari library, which is there in the JDBC. So the Hikari will allocate or create the connection with the database. Okay, so now here at max, as it can create 10 connections, so the Hikari will be able to create 10 connections at the initially. But post that, for these next set of requests, when they ask the Hikari to give the connection, at that moment it will not be able to do, because it can maximum create 10 connections. So in that case, those requests will go into waiting state. And how much waiting state they can be, that we define through this connection time. Okay, so here it's 250 millisecond, that is 1/4 of a second. So that's a very less time where we have defined. So if that request doesn't get a new connection within this time, then that request will get failed and the database operation will not get executed. Okay, so now according to our need, our requirement, we should set this time. Okay, so now initially I have set it to 250 millisecond, and this is a default value. Maximum you can set it whatever it is needed. Okay, so that's about the connection timeout. So we'll come back to all these properties once I will show you the demo. So I hope you are able to understand these three. Next, we have the idle timeout. So now coming back to these two, when we started the application, we have 5 idle connections. Okay, and maximum it can create 10 connections. Okay, so now when we have these many requests and the application has created initially 10 requests, among that 5 can be there forever and another 5 can be removed if they are not in use. Okay, so now here this time will tell that when those extra 5 connections should be removed by the Hikari pool. So that is what this 10,000 millisecond, that is nothing but 10 seconds. So those extra 5 connections will get terminated after 10 seconds if they are not in use. Okay, so the 5 connection will be always maintained, they will not be terminated, but the extra 5 which got created because of the higher load and post once the load has been reduced, the Hikari pool will check after 10 seconds that whether those connections are in use. If not, then those will get terminated. So then finally we will be left with the 5 idle connections. So that's about the idle timeout connection. Next, we have the max lifetime property. So this is set to 30 seconds, right? Sorry, it's set to 30 minutes, not 30 seconds, it's set to 30 minutes. So what is this? Now this is for these idle connections. Okay, so what happens once we have created this pool of 5 connections and they are persisted throughout the life of the application. So in that case, sometimes the database like removes those connections if they are stale. Okay, so in such condition, what the Hikari pool will do, after every 30 minutes, it will just terminate these connections and it will just re-establish it so that the connection will remain in an active state. Sometimes they goes into sleep state because of database or some other issue. So to avoid that and to make and to keep these connections always alive to serve the calls, the Hikari pool will make sure that after every 30 minutes, it will just terminate them and re-establish those connections. So that's all about these 5 properties that are really important to create a proper connection pool. Okay, so now let's execute, let's run the application and let's see different scenarios, how the behavior change. Before that, let me just show you now the database. So here I'm using MySQL Workbench to connect to this database, which I have created already. So I have connected to this. Here I have created a simple database that is demo. I'm using that, and then here I've created a simple table having the ID and count, and in that table I have added this data where I have 10 rows with ID as 1 to 10 and initially count as 0. Okay, so now if you check here the max connections, you can see that this database will allow me at max 60 connections. Okay, but we have set it to 10 at max. So what does that mean? We can still have 6 instances of this application. Okay, 6 more instances we can create where each instance can have 10 maximum connections to the database. Okay, so that is the reason. Now this is set to 60. Now this will depend on the size of your database. So I have created a very less test database with 1 GB of RAM. So that's the reason I'm getting only 60 maximum connections. But if you create a larger database, you will get more number of connections. Okay, so right now if we check this, the threads connected, you will see that 5 threads are connected, and those are some internal threads that the details we get over here. Right now in the application we have not yet started. So once we start this, we will see our connection also in this list. Okay, so now let me show you what we are running here. So here we have created 10 threads, and now all these 10 threads will execute an update statement that will update the row, and that is the count respective to that ID. Okay, so now let me run this and let's see what will be the behavior. Let me just open it here. Okay, so these are the initial configurations. So let me make it as 0. So that, what does that mean? Once the application starts, it will not establish any connections by default. So it will only establish once we have any request. So we are doing that over at this line where we are updating the database. So once we run this, it will first establish that connection and then it will execute the this update command. Okay, so let me now start this and let's see what will be the behavior. Okay, so right now if you see here, I got some error like failed to obtain the JDBC connection. So what does that mean and why did that happen? Let me just explain you. So once all the 10 threads started to do the operations simultaneously, so some of them were able to get the connection within that 1 second. Okay, so some of them were able to get it. So let's check how many rows got updated. Okay, so if you see here, we were able to update 1, 2, 3, 4, 5. Okay, only 5 threads were able to get the connection within that 1 second, and other 5 threads got failed within that 1 second, within that 1/4 second of a second, and due to that we got this error, and those 5 rows were not able to get the update. So this will happen when we set the connection timeout to the least. Okay, and here we did not add any idle connections because we like that means the application did not created any connections beforehand. So now let's do some changes here. So let's change this to 5. So now what does that mean? Now the application will first create 5 connections and then it will completely start, or then it will execute this code. So before that, let me just reset this to initial table. Okay, so now everything is reset. Now let me restart this and let's see now what will be the behavior. Okay, so if you see here, now this time it got succeeded, where all the rows were able to succeed because Now this time we already had a connection pool of 5 threads, that we used once we started this. So what does that mean? At the initial 1 second, we were able to use the existing 5 threads, and whatever the new threads that were needed, that was also able to get it within that 1 second. And we were able to successfully update all the 10 rows. So now if we check, we'll see that all the 10 rows we were able to get it. So this is the first change where what we did, we increased the pool of connections. Okay. So now here, if you see in the logs, you will see that Hikari logs, where now we should have at least 5 active connections. So here you can see we have at least 5 active connections. That is, so initially we had more, but it got reduced after 10 seconds. After 10 seconds, you will see one of the thread got reduced. So it does not mean that we have 10 threads, so it will create 10 database connections. Okay. So one database connection can be used by multiple threads. So that's again possible, because a database operation from this application to the database is very minuscule. Like it will take very less time. Within 1 second, there can be thousands of operations. So that's the reason one application thread can have like multiple application threads can be used for one database connection. Okay, so I hope you were able to get it. And here you can see that the 5 alive threads, it is just logging in, and these connections will get reset automatically after 30 seconds. Okay, so this was the first scenario. Now we can able to achieve this without connection pool also. If I make it as 0, and now if I make this as 1000, so what does that mean? Now I am making the waiting state, that is the connection timeout, to 1 second. So now let's check whether we will be able to achieve this or not without any connection pool. So for that, let me again reset this. Okay, so now let me run this. Okay, so again this time also we succeeded. So now what was the change? So we reverted back the connection pool to 0. So that means we did not had any existing connections, but what the application was able to achieve within that 1 second, it was able to achieve the multiple database connections, and it was able to complete all the operations. So at maximum, I think it created 2 connections. So at maximum, it just created 2 connections, and only those 2 connections were able to serve these 10 threads. So that means within that 1 second, so many operations were able to complete. That is 10 operations were able to complete, and for that it just used two threads. Okay, 2 database connections. Sorry. So that was the one of the change. So now let's take on one more scenario where we will increase the number of rows, and let's see whether with the same configuration we will be able to achieve or not. So let me increase it to 50, and let me reset this. Okay, so now we have 50 rows. So now let me restart this, and let's see whether we will be able to update all of them. Okay, so again we were able to achieve that. So here also we were able to use just 2 database connections, and we were able to achieve. Now all this is possible because now we have increased the connection timeout to 1 second. So 1 second is more than enough to complete all these 10 operations. Okay, so one thing we missed to update here, that is the thread count. So that's the reason you will see that only 10 rows would have updated, not many. Okay, so let's revert it back, and now let's increase the threads, And then now let's see what will happen. What will be the result? So this time I think it should fail, right? So now why did it fail? Because now the number of threads were increased. So that means the number of threads in the waiting state are more, and the number of connections within this 1 second are less, right? So that's the reason it got failed. So initially it tried to create three database connections. So with those 3 database connections, within that 1 second, the number of updates it was able to do, it did. But after that, the other threads which were in the waiting state, those got failed. So now if we check how many rows got updated, so you will see that. So it has significantly updated many rows, but a couple of them got failed, right? Like 1, 2, 3. Okay, so that's not a bad result. So almost, I think the 5 rows were not able to, that is nothing but around 5 threads were unable to get the connection. So now this can again be corrected by increasing this timeout to, let's say we'll just increase another 500 milliseconds. And now let's see whether we were able to achieve those 5 rows or not. We were able to update those 5 or not. So for that, let me just reset this again. Okay, now let me rerun this. Okay, so now here, so here you can see that we're able to successfully update all the 50 rows just by increasing 500 milliseconds. So within that 1.5 second, it was able to get all the connections. All the threads were able to get the database connection, and it was able to complete the operation. So this time it used total 4 threads to complete all the 50 operations. Okay, so I hope you were able to understand the concept of connection pooling and how it helps. So like this, you can just play around this. I'll be sharing this code, GitHub link in the description. You can just use that, and you can just play around and understand this connection pooling. And so for the production systems, we need to do a load test, definitely, with all the major queries, like which we are trying to hit, or which we expect will get the maximum hit. So on that, we need to do the test through changing this configuration, and then we can just come up to some data which will help us to establish the minimum idle connections and the maximum pool size for each instance. So now here, this one instance can have 10 connections maximum. So like that, if I run multiple instances of this application, then each can have maximum 10 connections. So now as the application is in the running state, and here we have kept idle as 0. So if we check threads connected, so it will be still the same because the idle connections will get terminated. So now if I change this to 5, and now if I run this again, okay, so now if I check it back, you will see that it will be changed to 10. So more than 10. If I check the process list, so now these connections will be persistent throughout the life of the application, because we have set the minimum idle size to 5. Okay, so I hope you were able to understand the concept of connection pooling and how to configure this and what is the essence of that. And let me know if you have any doubts in the comment section.